So Leo, before you move on, so I would say what you have done here is actually okay, except that we need to change a little bit here. So when you compare in the comparison here, you cannot compare from two different loops. So you actually, if you have something like that, so you actually comparing this to this. So it means that in the inner loop, you are comparing j to j plus 1. Okay, and so it means that you should be looping from 0 until 5, 9, 8. It is acceptable that you do it. This is the worst case. It means that you really have to loop to all the array. But the smart way is to put minus I. So every time this I increase, this means that the inner loop will actually loop less. Do you understand? Because you will be subtracting from this. So when the I is 1, so now on the second pass, so you will be looping 5, 9, 7. And when I increase more, so sorry, it's your I here that you put is a small case. So to avoid confusing you, minus I, like that. So when the I here become maybe 5, let's say 590. So you subtract 590 from 598. So you find yourself looping only from 0 to 8. Does this make sense to you?
Yes.
Okay, I think so. That is part of the bubble sort, but this is pseudocode implementation. What you have done here is okay. It's perfect. You can just use temporary 1 or temporary 2, but okay, what you have done is excellent, except that the part that I'm telling you. Okay? Does it make sense?
Yeah.
Okay, so Leo, I want you to note one thing. In this exercise, he is telling you in the A part. So he is telling you that you should be that actually the names is a collection. And so you are putting from names. So names, M-E-S, names is actually a collection. And the collection have get next. This is in pseudocode, okay? And it have a reset function, okay? So the point here that you should use these two. So reset next means that if you have a counter, you will reset it to the start of the collection. So before you do anything, you have to call this reset next here before your loop. Sorry, I didn't do correctly here. It should be yes. Okay, perfect. So what I want to say is that it should be, yeah, you can call it here above or even before the loop. You should put it here, somewhere here. Okay. So this is for the reset next. And then the point here, what you are doing is you should get from names and put inside surnames and first name, not the reverse. You're reversing it. And I also would like to understand from you why you need to put 2 to multiplied by count. This is I'm not very sure why you put it like that. So it should be surname count, and I will delete that. equal names and first name equal same name dot get next. So this is because it is names is a collection, and as I said, you put here names dot reset next. Okay. Uh, if you can give me some idea why I can't really get the point in why you are putting two.
Well, I was thinking that it was an array, and if it was an array, then it would be going like surname, first name,
Uh-huh.
surname.
Okay.
So in that case, like if there's like the index, if we're going from 0, then the surnames should all be even number indexes, and all the first names should be odd number indexes.
Uh-huh. Okay. Okay. Um, okay. Anyhow, so as I said, names is a collection, so you have to use that, um, and you have to assign. That is also, yeah, you have to assign names to. So you have to understand. Well, the declaration is not a must. I mean, it's an optional. If you don't put it, you will not lose marks. You have to understand every line you write correct. You get a mark for it. Okay. Now you can continue, please. Ignore number C.
Oh, okay.
Just go to the next. So okay, let me just interrupt you um, to tell you a summary of your answer here. This is okay. Then let me go from here. So the GPS need at least 3 satellites, okay? And the information that so the information that comes from the satellite is actually coordinates and the atomic time, the atomic clock time that the satellite have. So every satellite have an atomic clock there, and then the time from the atomic clock and the time from the receiver is actually subtracted together. So if a person is standing here, okay, on the Earth, and so we need 3 different satellites that send signal like that. At least 3, some resources say 4, okay? And every one of those actually somehow create some kind of sphere, okay? And the actual location of that human is actually the how to say the intersecting paths of that spheres. So for every satellite, we have a sphere that is created when it's received by the phone of the receiver, okay, or the GPS of the receiver. It can be a person, can be a train, or whatever. So for example, if you see here, there is 2 spheres, but then the sphere intersects in 2 paths. So which one is we are able to say that the receiver is there? So there is here intersection and also at the bottom intersection. So there we need the 3rd sphere, which is the Earth itself. Only then we can discover and say that the position of the receiver is here. So that's why sometimes if you receive only signal from 2 satellites, that's not really enough to actually decide your exact and exact location of the receiver. Okay, and of course this GPS signal always have maybe plus or minus a half meter or 1 meter accuracy, so it's not very accurate. So this is if we talk about how the GPS work. But again, just be aware that that we need to talk about GPS more when we talk about the rescue robot. So let me see. Did I manage to explain it correctly, or did I manage to clarify it to you?
Yes, that was fine. Yes.
Okay, let me see here. Okay, so if you're talking about arrival data, so the problem is why we need extra sensors other than GPS. GPS can always work, but there can be blocking somehow if the train enter a tunnel. So it means that we will not be able to have accurate information about where exactly is this train. So we can put motion sensors or vibration sensors on the trail itself of the train. So from there we are able to know information about the train, where it is located at the moment. So besides that, we can also put some kind of sensors before the train station. So on both sides of train station, so imagine that you have a train station in the middle here, and you have the trail lines here, and then I would say, imagine that this is a train, and it's coming from this direction, and also there is a possibility that some trains can also come from the other direction. Okay, so we put sensors before the train station in both directions. And if we know that, so if we know where we actually put the sensors, that if it is cut by the train when it is crossing, then we will know, okay, so this is, for example, 1 kilometer. So by knowing the speed, or by knowing that this train already crossed here and this sensor already 1 kilometer away, so we are able to actually estimate by knowing the normal average speed of the train. We know that, okay, it will cut or it will pass this 1 kilometer in how many seconds or how many minutes. So we are able to tell, okay, so it's that minutes away from the station. So if we put the sensor here and here, then we are able to detect. So does this make sense so far? Okay, so the point here that yes, you already tell good advantages, and one of the disadvantages, like you said, is a weather condition. Bad weather condition will actually not make you able to receive good signals. Also, one of the disadvantages of GPS that privacy concerns. You have privacy concern of making you the train and or the people who are operating GPS, that their location will be available all the time. Okay, and that's why they raise concerns about Google that is tracking human because of the GPS signals inside the phones and so on. So that is from the GPS point of view. Now let me try to go back to questions regarding paper 3. So to actually try to, yeah, the most dangerous thing here, let me see. Okay, yeah, that is the most dangerous question actually, because it's the amount of marks that you have to answer here, or it's the amount of marks that is assigned to that question. So I would say the danger and concern associated with the rescue robots. So concerns is the GPS. The GPS will not function indoor, okay, and also the amount of network or bandwidth that's available. So if you use only a GPS and depend on network for the rescue robot, it will not function properly inside buildings. So this is challenges or concerns, and so you have to talk about that. And then to solve that, they use a VSLAM. So the VSLAM actually will be able to build the map using cameras and using sensors, and it will be able also to position to track the rescue robot position inside the building. So he will build a map, and then he will localize and able to map himself or tell where is he inside that map that he built. Okay, and what is the HPE? So the HPE is actually the algorithm that will. So if you have a human like that, and that human, sorry for the drawing, horrible drawing. Okay, so if we have a human like that, so the pose is actually going to draw um, somehow points like that to mark the movement or to mark the human body. Okay, so it will mark the human body by marking the human body with information, or even locating the human body parts and its movement. And even if it is not moving, it will still mark it. So by doing so, he is able to recognize humans or even the movement of a human. So if a person have something on top of his body and he is sleeping somehow and he's just able to raise his arm, so the robot are able to actually recognize that using the HPE algorithm. Okay, I would say the VSLAM will have errors. So we need algorithms to actually improve the VSLAM maps that is created. And one of them is a global map optimization. And we have odometry sensors that we are able to install inside the robot. Also, it will have errors. So they will use other algorithms to be able to fix that errors. Like just let me explain that on a later stage. So again, as we said, VSLAM and HP algorithms will be able to make the robot actually function. It will make it draw maps. It will be able to make poses on humans or even recognize human bodies. It can signal or even recognize human movement if there is in any. But the point here is that you have to draw analysis in your answer. So this is analysis of the situation. You have to come up with a conclusion, and you have to cite research. So you have to say that, okay, which university talk about robots or have done some research about robots, which companies, I think there is something like robotics PI, or there's a company that is working on rescue robots that is also using VSLAM. So mentioning that in your answer actually will help you get the full mark on that. This is just in summary. So what I would say is that I think I already somehow answered you here. Let me explain how code can minimize. Yeah. So to be able to answer you here, the point here is that you have to minimize. There is a few techniques actually you can use. One of them, you minimize the amount of features that you need to actually recognize, to be able to find to do your mission. So why your mission is to rescue people. So I would say to rescue people, you have to focus on important things. Okay, so no need to go and build a whole map one shot, um, um, and then start to go and search for people. So by prioritizing that you build from the map as you go, as you move, prioritize that you want to search for humans, for people who are need help, and prioritize the, things like doors or windows or doorways or open spaces or places you want to deal with. Um, you should, while prioritizing that, that will take less time to be able to rescue people. So you don't build the map first and then you decide to search for humans, or even for important places like doorways or open